This is my White 4 post-lab work for Adam Kawanya. Okay, so number 1 asks, why do you need to heat the clean crucible before using it in the slab? And why do the tongs used throughout the slab need to be especially clean? You burn the crucible so that you get rid of the leftover residue, and the tongs need to be cleaned so you don't mess with the measurements of the data through adding extra oils or chemicals to your crucible. Number 2 asks, why do you need to use a cover for the crucible, and could you leave the cover off each time you measure the mass and its contents and still get accurate results? The crucible covers is to prevent minerals from splashing out of the crucible so that the results aren't altered. And no, you always want to leave it covered, because if you leave the cover off, the minerals would splash out and then your data would be changed. Number 3 asks, calculate the mass of anhydrous copper sulfate by subtracting the mass of the empty crucible and cover from the mass of the crucible cover and heated CuSO4. And then use the molar mass for CuSO4 determined from the periodic table to calculate the number of moles present. Oops. Number 3, 22.83 comes from the initial mass of sample, crucible, and cover, and then the 17.83 comes from the mass of the empty crucible and cover, and you subtract those two and get 5. And 5 is over 159.62, which is CuSO4 in molar mass. You get 0.031 moles. Number 4 asks, calculate the mass in moles of water originally present in the hydrate by using the molar mass determined from the periodic table. Number 4, the mass of water is 1.82 because you subtract 22.83, the initial mass, minus the mass of sample, crucible, and cover after the first heating, which is 21.01, and you get 1.82. And you do 1.82 over 18.016, which is water or H2O, and you get 0.101 moles. Number 5 asks, explain why the mass of the sample decreased after it was heated despite the law of conservation of mass. And the water evaporated from the heat of the crucible by the Bunsen burner flame is why the mass of the sample was decreased. Number 6, using your answers from items 3 and 4, determine the empirical formula for the copper sulfate hydrate. Okay, so number 6, I have my 0.101 from these moles, and then my 0.031 from the other samples. And you get 1, and you divide them by the smaller number, which is 0.031. So you divide 0.101 divided by 0.031, and you get 3. And you divide 0.031 by itself and get 1. So it's 1 copper sulfate to 3 water. Number 7 asks, calculate the percent water in your sample. So you have your 1.82 from the 22.83 minus 21.01, and you get 1.82 over 5, which is 22.83 minus 17.83, and you do it over, and then you get a decimal, which is 0.364, but you have to multiply that by 100 to get a 100, so you get an actual percent sign. And then for number 8, it asks, calculate the percent water in a mole of copper 2 sulfate pentahydrate using the formula. So the first one, you get 90.08 from the molar mass of the 5 hydrates, the 5 waters, and you get the 249.7 from the copper sulfate plus the 5 waters. The mass is added together, and you get 0.361, but you also have to multiply that by 100 to get your percent sign, the equation, and you get 36%. And then number 9 asks, calculate the percent error using your answer to number 7 as experimental and to number 8 as accepted. So you do 36 minus 36, which are your percent signs, and then over 36, which is, and those are the experimental, over the 36 on the bottom, which is the theoretical. You multiply it by 100 and get 0. So I think that this example of the CuSO4 is the right substance for moisture absorbent indicator, because I have a 0% rounded to 0% equation error. So I think that's the right for the job. Thank you.